SpaceX is behind. Behind what? There's something called the AI race that everybody now talks about, and we want to try to define what that even means. And Musk actually answered to somebody who said that DeepMind is destined to win the AI race. Musk said maybe for a few years, but then SpaceX will let everybody else way behind. So this is the conversation. On the one hand, I think frustrating for us that somebody like DeepMind can outperform SpaceX when you just think of the talent density and the enthusiasm and the energy of SpaceX versus the sort of bloated academic, sophistry of Google. But then you also have to admit Google has been at this for 20 years, and X and SpaceX. When I say SpaceX, I mean SpaceX and X, and actually Tesla. So I'm going to put all the three together into one and call them SpaceX from now on. And the reason I want to do that is because the big breakthrough that Musk is seeing for SpaceX is that you can get rid of two constraints at once. One is space, the other is energy. And that are the two main constraining factors right now for AI to grow orders of magnitude from where we are today. So this is the conversation. And I think what Musk said is true for the next few years. If you compete with space and energy, then it's very difficult to catch up with the incumbents. There's one caveat though, and that is if you can change the application, which Tesla is doing. But then fundamentally, once you change the constraints, all bets are off. This is the Not Even Wrong podcast. It's March 16, 2026. This is Crimdalco for the year. We're down 10.5%. The market's down 2.5%. We're underperforming by 8%. So Musk said that for a few years now, DeepMind is winning the AI race, and then eventually SpaceX will let everybody else way behind. So let's first talk about what that actually means, the AI race. So the AI race is kind of three things. One is the build out of terrestrial data centers. Number two is developing models that are very powerful in doing digital work. And three, having a large user base. So those are the three things that are intertwined, of course. And on those three factors, currently we have Gemini, which is Google's foundation model, ChatGPT, which is the OpenAI model, and Anthropic, which is, Claude, which is the Anthropic model. So those three are way ahead particularly in two things. In one thing, and that is user base. So the market share of those three is probably about 80 to 90%. So meaning anybody who's using digital AI tools, digital versus real world, so real world AI being things like robots, cars. So we're not talking about that. We're talking about digital AI tools. So if you want to use an agent to write a piece of code, if you want to use an agent to write a piece of marketing collateral, or develop a video or a movie or something like that. So any kind of work like that is dominated by those three. And as far as powerful and performance of the models are concerned, I would say Grok is actually much better than any other model when it comes to delivering truth. So results and what I mean with truth is not just the political truth. So what is a transvestite or what is should you misgender people? Not that stuff, but real truth. Like, for example, how do I value a company? What are the main accounting problems to solve in valuing data centers? Like things, real work. Grok's already better, but it's not being used, and you can console yourself that there's the fool that doesn't know what to do, and then there's a double fool that doesn't even know what she doesn't know, and that's what most of the AI community today is. Like, they're just using those tools because everybody else is using those tools and they're missing on the real powerful application of Grok. And by the way, also other models, for example, the Chinese open source models are also very close, if not better than some of those three, but they're not being used for whatever other reason. So when it comes to the third factor, which is the actual infrastructure build out, the physical AI there, I would say it's by far the most open race, and X is definitely, SpaceX is in a leader in that space, but not by enough. So meaning you can't outbuild the others to the point where you can also outperform their models. Just I think the cadence and the iteration is too slow there. So having said that, now we are in a situation where, again, if you want to write code, if you want to write marketing collateral, if you want to ask AI which lipstick to use, whatever the use case is, then we see that even Musk is acknowledging that they're behind. Now, why is that the case? I think there's two reasons for that why SpaceX is behind. Number one, they started late. Number two, they didn't do the right build out because they focused on the wrong metrics. Now, the details I'm not familiar with. I'm just paraphrasing what Musk said on X. We need to rebuild X. People left, new people came. So there's definitely a rebuild. We've seen this before with Musk, with Tesla, with SpaceX, with Starlink. Teams get replaced, not because they're not capable, it's just they're on the wrong path. Now, I want to say a few things about what he meant with in a few years, SpaceX will let everybody else way behind. I think the thinking there is that once you break through the double constraint of space and energy, which you can do in space. So in other words, you have hundreds and hundreds of miles of square miles of space. I mean, you have basically unlimited space up there. So you don't need to cram the satellites close together, and you can use optical communication to link them together at the speed of light, which at in the 100-mile range, if these things are separated by hundreds of miles, then it's still like for the speed of light and the latency, that's not an issue. So in other words, space is actually one of the bigger constraints that we rarely talk about. We talk about energy, which these things are of course intertwined, because the more tighter you cram chips, the hotter they get, and therefore the more energy you need to cool them. But nevertheless, I think having more space is a big deal. And by the way, there's the other thing, the NIMBY problem, which is becoming increasingly a problem. And that's not even in this equation. If you add the NIMBY problem, then of course I think everybody understands very quickly that space is a big constraining factor. And when we talk about scaling here, we're talking about orders of magnitude scaling. So we're talking about 1,000, million times more data centers, more compute. And the reason that is actually feasible is because in space, again, you're not constrained by space and you're not constrained by energy, assuming you can capture 30 to 40% of the solar power and then cool these things down to the level that's necessary, harden those things, and of course, also assuming you can actually launch the satellites at a cost that Starship is promising. So I think that's what Musk means when he says we're going to leave everybody behind. Now, this brings up the $100 billion question or $1 trillion question, and that is, well, is there enough demand for this kind of compute? I mean, one thing is if we keep scaling, but why is there so much demand? And I think we've spoken about this before. Intelligence has unlimited demand because intelligence creates its own problems that then can be solved with even more intelligence. So this is a flywheel, an avalanche, actually. We call it an avalanche because it grows avalanche-esque. For people who aren't familiar with the exact reasoning, there's, on our website, you can search for maybe Karl Popper, epistemology, David Deutsch. Those types of episodes talk about the actual, theory of knowledge and how knowledge creates its own demand. So this is a self-fulfilling prophecy, if you will. It's maybe in physics terms, maybe there's a contradiction there. There is no preservation of knowledge at all. Like knowledge can grow, at least from our perspective, close to ad infinitum. Maybe there's some sort of limit. I don't want to go there. I mean, that's not relevant for us right now because, again, in a much simpler way, once we figure out how to make lithium-ion batteries, then the knowledge of how to mine for lithium or the knowledge of how to reduce the doping necessity with cobalt, because we don't have enough cobalt, becomes more prevalent. Once we figure that out, then maybe the knowledge of how to link batteries together to create distributed systems. So every time we come up with new ideas and new technologies, we create new problems and new technologies, which, by the way, also solves the job problem. I think there's plenty of productive jobs to be had for humans, but that doesn't mean, of course, that everybody will have a job. That's a different conversation also that I don't want to go into right now. Fundamentally, though, intelligence is infinite demand, and therefore we can scale up orders of magnitude more compute and deliver monetizable intelligence. Intelligence monetizable if it solves human problems. This is a working assumption that we have. Now, that doesn't mean that there is intelligence out there that can solve, agentic problems, but the biggest value added will always be where agents interact with humans. And by the way, that's not work. We don't think that, work or facilitating work is necessarily the biggest driver of demand and profit, but it's actually more convenience, safety, and lower cost of doing something. So when humans find ways to, let's say, do transportation or get from A to B at much lower cost, much safer, that's when they're going to be ready to pay a lot of money for these types of services. So what we're saying here is, and this is now the segue into where we see Tesla's competitive advantage going forward, is that they have the products and services in the real world to iterate around intelligence products that can scale up orders of magnitude of compute. For example, the Cybercab network will create its own demand of intelligence, managing the network, scheduling the network, managing the optimi to maintain the cars, managing the cars themselves, managing the production of the cars and the networking of the production, the supply chain. All of these things will be agentic and have their own use case that Tesla can iterate around. And I can't emphasize enough how important iteration is, because, yeah, you could buy off-the-shelf technology from NVIDIA or somebody else, but if you can full stack iterate yourself around the intelligence to solve those real world problems, the chances of success and the chances of having useful products are just much higher. Again, I'm not saying that others can't do it, but if you can iterate around the use case yourself within your own ecosystem, you just have a much higher probability of success. So to summarize, we believe that the future of SpaceX is in space-based AI, that creates a huge amount of intelligence or tokens. They will not be constrained about with wattage and square footage. So we're taking two massive constraints out of the equation, which is space and energy, creating a forcing function for much more compute and intelligence. The intelligence has infinite demand, so we're not concerned about demand. The only skill that the entrepreneur needs to master is how to iterate around the use cases to create useful products and services. And Tesla is well positioned as a fully integrated AI factory to do that. Thank you.